Hello everyone, welcome to week 10. So this week it's actually in the middle of the semester, and you are currently have multiple assignments or tasks ongoing. So I want to point out one thing that firstly at the start of this video, which is that you will have a semester project folder posted, and where you can access the detailed requirements of the semester project. And another thing is for you to write an ethic paper. And so both the semester project and essay papers, so you will find that there is a special things called a rubric for grading. So that's a thing that I want to point out at the start. So if you click view rubric, and you can see there are some grading details that I will follow, so that you can know like how you need to finish the assignment so that to get a higher grade. Okay, so this actually they are the criteria that I will use to grade it. So that's a good thing for the assignment of this course, that almost most of them, like a big project or assignment, they have their rubric. Okay. So this is the one that for the ethic paper, and the one for the research paper. Okay, so there's also a research paper rubric. So in case that you have not checked it yet, so or if you have not, if you did not pay attention to that. So for example, I think there should be a link for the assignment, which should be probably this one. Okay, so if you click the final version for the paper, so you can have the rubric link here and see the details of the rubrics. Okay, all right. So for this one, the topic coverage, topic focus, and the depth of discussion, clarity and organization, and spelling and grammar, sources, citations. So the research paper will be based on this categories and for different levels. All right. So all right. So just make sure that you will have a double check with those okay rubrics. And similarly, if we go to the, let's see, research paper semester project. So if you click the semester project, so you can see the rubric too. All right, so this one will be graded based on the categories of teamwork, entity relation diagram, and website functionality and presentation video. Okay. All right, let's dive into this week's content. Okay, in the slide. Let's see. Okay, I will start presenting. So this week we'll be talking about the transaction management. Okay, transaction is a very important actually concept for any type of database systems. Okay, so mostly you should be learning that. So during the undergraduate database management system courses. So so this the mostly the transactions, you may learn the basic knowledges about transactions in the undergraduate course. However, we will get some idea of how the transaction management be completed, like within the distributed environment. Okay, so we will dive into more like distributed features in the following weeks. So it means that we will spend like 1 to 3 or almost probably 3 weeks like on this topic. So the first week, like this week, will review the basic knowledge or concepts of transaction management, okay, which you have probably have learned before. So first thing, what is a transaction? A transaction is a collection of actions that make consistent transformations of system states while preserving system consistency. Okay. So basically, so it's a mechanism that assure that the the state of the database would be consistent. Like they could be the stages could be like there would be a begin transaction, end transaction, and all the operations can happen in between. And so this phase, this transaction will not be bothered by the other transactions. And also, um, so at the start phase and the end phase, so the database will be in a consistent state. All right. So during the execution of the transaction, the database may be temporarily in an inconsistent state. Okay, so however, the transaction works as a wrapper of those operations or execution steps. So it can provide concurrency transparency and failure transparency, which means that so we will not, our users of database will not notice any concurrency of the transactions or failures occurred during the transactions, which means the transaction will had all those concurrency details or failure details. All right. So that's a transaction. And one example, this is a simple SQL query. We can have a keyword transaction, and this is transaction name. As we can see from the name of it, the transaction is for updating the budget. Okay, so then it followed by a begin keyword and end with an end keyword. Okay, so so you probably can see this type of SQL query scripts inside database management like your GUI, and you can run the transactions in that like database management like a tool. Okay, so or it could be written in like code or Java code or PHP code or some other like code involves with the SQL transactions, and it can build in those SQL query. Or there could be similar transactions like involves with like databases, mostly databases. Okay, so similar code like to handle the transactions in the program level. So and you can see the similar code style. All right, that those keywords and styles can depends on different platform, different languages. All right, this script mainly, so we can see that it's to set the budget to budget times 1.1, which is to update the budget. Okay, and by multiplication with a number. So we just update this project table and set the budget where the P name is, it could be a project name is a CAD or CAM. All right, so this is the transaction, which means that this execution of this this update is wrapped with a transaction. Okay, this is a simple SQL query transaction example. So next we will have some more complex transaction examples. So consider a database for airline reservation a business. So there could be 3 tables. The first one is the flight. It contains the flight number, the date of the flight, and the source, the like location, destination location. And seat sold, it's the seat that has been sold. And cab is the total number of the seats of the flight. The customer table could contain the customer name, address, or balance. Okay, so the FC actually is a connection between the flight and customer, which means that if a customer have booked a flight, so there could be a tuple in this one, so that it can record that which flight number the customer have booked, and also when would be that flight, and what would be the special request for that flight, for that booking. All right, so this is the example database, and let's see. This is the example transaction with two steps or two executions, like the SQL script. The first one is update. So this update operation will just update the seed sold to increase 1. Okay, and for insert, it's to insert a FC tuple, okay, with F number and date and C name and special. So values with this, this is connected with the input. So this one, as you can see, the output is the reservation completed. So this is the transaction for booking the flight or like make a reservation of the flight for a customer. And it involves with, it should be completed, like if it's easy like for us to understand it, that those two operations should be completed at the same time or at a same at the same like execution simultaneously. It's because that we have updated the seed sold plus 1, and also we have insert to the table. All right, so suppose that the first one is updated, however, the second one is not updated, so that will cause a problem. All right, so that means that it either success together or it will fail together, so that it will not, if it fails, it will not make any modification to each of the to the two tables. All right, so and another example is that about the termination of transactions. Similarly, we have input of flight number, date, customer name, and executed the SQL. We will select some information from the table of flight, right? So we just get the system sold and cap. If the system sold equals caps, which means that the number of the seat sold has reached to the max number of the seats that the flight can hold, which means that there could be no more reservation for that flight, right? So if temp 1 equals temp 2, then output is no free seats and just abort the transaction. Else, the two operations will be executed simultaneously at the same batch, and then finally it can commit the two execution. Okay, so and then output the reservation completed. All right, so that's the end of the reservation. So this example is just for is to show the aborting of the transaction, which means that transaction can be aborted based on some conditions. Okay, so the conditions, the data can be selected from the database, like based on the current status of the databases, the data of the databases, so that we can decide whether to abort the transaction or not. All right. So this is example transaction for read and writes. So, all right. So I think this is just another version of the one that we just illustrated, like in the prior slide. Okay. So as you can see, we can conclude that there should be some principles of transactions. So it's called ACID. ACID is acronym, like in short of like admissivity and consistency, isolation, and durability. Let's talk about them like one by one. All right. So admissivity is like either all or none. Okay, so it cannot like just happen like half of the execution of the steps being executed and the other half not being executed. That's not admissivity. The admissivity is like either succeed or not, or just roll back everything. All right. So admissivity requires that if a transaction is interrupted by a failure its partial result must be undone, and the activity of preserving the transactions automatically in presence of transaction aborts due to input error, system overload, deadlocks is called transaction recovery. And the activity of ensuring admissivity in the presence of system crashes is called crash recovery. Okay. So these are just some terms that are like related with admissivity. Consistency we are talking about is related with internal consistency. A transaction which executes alone against a consistent database leaves it in a consistent state. And the transaction do not violate database integrity constraints. Okay. So so transactions are correct programs, which means that so after the execution of the transaction, so the consistency should be preserved, and it will not violate the database. There could be some integrity constraints like between the table within the tables. So for example, so the transaction does not violate them. Okay, so. And there could be different degrees of transaction, like it could be the degree 0 means that the transaction T does not overwrite dirty data of other transactions. So talking about dirty data, so it means that there could be, so we will talk about dirty data in later slides. However, dirty data is some intermediate data caused by some other transactions. And the dirty data refers to data value that has been updated by a transaction prior to its commitment. Okay. And T does not, so for degree 1, T does not overwrite dirty data of other transactions. T does not commit any writes before end of transaction. All right, so there are another 2 consistencies degrees. So as you can see, the last one, the degree 3, it has it's talking about like more things, like it has T does not overwrite any dirty data, and T does not commit any writes before the end of transaction. T does not read dirty data from other transactions, and other transactions do not dirty any data read by T before T completes. Okay, so so based on like different type of like applications may require different consistency degrees. For example, if it is like a task like critical applications like banking systems, so the degree of consistency should be the highest. However, if it is a gaming application, and some users may read some dirty data caused by like transaction issues or programming transaction issues, so it's fine like to read some dirty data. So actually, so it depends. Okay, so we can apply different consistent degree like to the like the transaction management. All right, isolation is another property. So it's talking about this serializability. It's involved highly related with serializability. Okay, so as isolation means that so if several transactions are executed concurrently, the results must be the same as they were executed serially in some order. And okay, so isolation, mostly isolation means that the transactions, they should be isolated with each other, and they will not interfere with each other. And finally, the result, the running result, will be the same and also will be consistent. So that will require that the management of the transactions or the code writing of the transaction be taken care of carefully. Okay, so an incomplete transaction cannot review its results to other transactions before its commitment. It means that so other transactions cannot like read the other transactions data. Okay. So if it is not complete. All right, so it's necessary to avoid cascading aborts. Okay, so here comes the example of isolation. So for the first, consider the two transactions. They are both of them. They are updating. They are calculating x and then updating the x, like by write x then commit it. So there are two transactions. So possible execution sequences. This is the one possibility, and this is another possibility. Let's look at this one first. So as you can see, the T1 will be executed firstly, and then T2, and it will not have problem because we just write them like in sequentially. However, for this T2, if we arrange in this way, so T1 will read X and then do some calculation of X, and then T2 will read X. Currently, this reading of this X will still reading the old value, okay? So there's no updating for the X yet, so this is still the read value. And this T1 will write X, and then T2 will do the calculation, and T2 will write X. So both of this X, they should be the same because of this calculation. They are the same calculation. So T1 commit and T2 commit. So this will be weird. Okay, the result will be false. It's because the value will only be added to by 1. So instead of by 2. So as for in here. So this one might not be the result that we want. Okay. So this is not a good example for isolation, and this is just means that these two transactions, the execution sequence will not be able to assure the isolation for the transaction. That's not a good one. So normally we will so especially for taking care of the data, so we need to pay attention to the order of this execution so that to make sure the isolation of the transaction will be achieved. Okay. All right. There are also some isolation levels. So there could be first there could be some different phenomena. The dirty read means that some transaction here is T1 modifies X, which is then read by T2 before T1 terminates. T1 aborts, and the T2 has a read value which never exists in the database, right? So that's 30 read. Okay, T2 just read 30 value like for X, and there's a second phenomena called non-repeatable read. Non-repeatable, we can also call it fuzzy read. T1 read X, and T2 then modifies or deletes X and commits. Okay, so and then T1 cannot read it again, or cannot read the same value again. So that's called a fuzzy read. And phantom means that if T1 searches the database according to a predict, well, T2 inserts new tuples that satisfy the predicate, and then T1 will find that why? So I just got some result from the database, and suddenly there's a new one. Okay, there's a new tuple. So that's called a phantom. All right. So there are pretty interesting terms that you can use, like by discussing some issues caused by the like a consistency or isolation issue, like for related with transaction of databases. So there could be different isolation levels called read uncommitted, repeatable read, and anomaly serializable, and obviously. So the last one, anomaly serializable level, will be the best one. So none of the phenomena are possible. So, all right, it's just like for you to review some of the related terms or concepts. So for the last one is the durability. Durability means that once a transaction commits, the system must guarantee that the results of the operation will never be lost. So instead of subsequent feeders, so which means that the data will be stored in the database permanently, like permanently, so that in the perspective of storing things, which means that it has to be stored correctly. So so that's it. So that's just like storing the the result of the transaction. That's called durability. There are some categorization of transactions. Okay, so based on application areas, there could be non-distributed or distributed transaction and compensating transaction, heterogeneous transaction. For the timing perspective, so there could be online. So it's just use this term. It means that it's a short life transaction, or batch transaction. It means that it's a long life transaction. So it could be a very long. A long transaction consists of like a lot of execution steps. However, for online or short life transaction, it's only like one operation, one update. Okay, that's because of the timing of the execution. So organization of read and write actions based on this one. So there could be a two-step restricted or action model tabs. So for structure, based on structure, there could be a flat transaction, nested transaction, or workflows. So we mainly will talk about several types of transactions based on the structure. The first one is flat transaction. This one is the most typical transaction that we have learned, or we have probably you have the chance to view them. They are just like being wrapped with the begin and end marker. So just as the example, okay, begin transaction and then begin another transaction and begin another transaction. This is the nested transaction. Okay, this is the flat transaction. The nested transaction is just similarly using this begin and end like marker. All right. Nested transactions, so it have the same properties as their parents and may themselves have other nested transactions, and introduces a concurrency control and recovery concepts within the transaction. The tabs will be like closed nesting and open nesting. So for closed nesting, sub transactions begin after their parents and finish before them. Okay. So, however, for open nesting, so sub transactions can execute and commit independently. Okay. So, and commitment of a sub transaction is conditional upon the commitment of the parent, which means that it has to be committed first, and then the parent can commit. Okay, and then the open transaction, the compensation may be necessary, so which means that it could be different with this parent transaction. For workflows, okay, talking about workflows, there are three tabs mentioned in the textbook. The first one is human-oriented workflows. Mostly it's talking about the workflows that involving humans. And the second one is system-oriented workflows. Mostly they are managed by the computers. Okay, so like the programs. So most of the workflows we are talking about in computer sciences, they are system-oriented workflows. Okay. So, however, the transaction workflows is talking about like in between the previous two, and it may involve humans, and it requires access to heterogeneous, autonomous, or distributed systems that support selective use of ACID properties. And I would say that mostly it would just like be very similar with the system-oriented workflows. It's because it's mostly programs will help the human to manage the workflow, the transaction workflows. It's talking about that it may involve humans. Okay. So this is an example of the workflow for the transactions. So for example, the workflow, it could be T1, T2, 3, 4, and 5. The 3, 4, they happen simultaneously, like in parallelism. So the customer, for T1, customer request obtained. T2 is airline reservation performed. T3 is hotel reservation. T4 is auto reservation. Okay, T5 is the bill generated. Okay, it makes sense for application like for Expedia, which can support like reserving the airline and hotel and auto at the same time. All right. In summary, the transaction provide the atomic and reliable execution in the presence of failures, and correct execution in the presence of multiple user accesses, and the correct management of replicas. So if they support it, so we will talk about replicas later in the following weeks. So there could be some issues like so there could be transaction structure, internal database consistency, and reliable protocols. So let's see, we talk about the transaction structure, the consistency, semantic data control algorithm. It's talking about the integrity constraints and reliable protocols. Yeah, we will talk about them later. So yeah, that's a similar thing. All right, the last thing we will talk about is about the architecture architecture revisited. In so this figure in this slide give us a very good concept about about the architecture thing involved by management of the transactions. So for transactions management, so in a distributed execution environment, there could be a distributed execution monitor component, which can include like two small components, okay? Two modules. The first one is the transaction manager, and the second one is the scheduler. For transaction manager in a distributed execution monitor, so it can handles anything about the begin transaction, read, commit, and abort. Okay, and also it will return results to the requester, and it will the transaction manager will work with the scheduler. Scheduler is a one which will communicate directly to the data processor so that they can do some actions. Okay, this one will do the jobs, okay, on hand. However, this one is just to manage so it's just to manage this request of the transactions. Okay, so the scheduler can schedule or deschedule the requests, and it can also work with the other transaction manager from a different distributed execution monitor, and also the transaction manager can work with some other schedulers. All right, so all right, I think that's everything like for this week for you to review the concepts of basic fundamentals for transaction management, and I hope this can serve well. It could be a good review, like to serve well for to dive into more features for distributed transaction management in the following weeks. So again, like just to as a conclusion. So just like you can read by yourself this chapter and read the notes and add to the notes, and to have more concepts, to be more familiar with the concepts about transaction management. Hopefully it can help you a lot to understand the rest of the content. And also, if you are interested in one specific topic or content, you can also dive into them. Let me know if you have any questions, and also if you have any questions with the midterms, the grading of the assignments, and also with any criteria or rubric of the projects. I know currently we are having a different task ongoing, and however, this is the middle of the semester, which means that, okay, we still have plenty of time for you to finish those tasks. And let me know if you have any questions with the things that we mentioned about. All right, so have a great week.